topics tonight. So let's move ahead. We have our agenda. So, of course, this is the past SQL Server, Silicon Valley, San Francisco group. Just like to always thank our sponsors for tonight that's covering the room and the pizza. We have a number of local groups, like Adele, Design Mind, Viera. Standard players, you've seen them. Say hello, thank them when you see them. They're the reasons that we can afford to bring people in like this. Past Summit 2014, coming up relatively soon. You all heard this before, you're on the mailing list. But if you're interested in going, you have one of the various registration codes here. I know this one's an obvious one to see, the C5M00ZPP. How they come up with these, I don't know. I'd make them a little more readable. But it's a great thing. I don't know who was able to go to the Business Analytics Conference in San Jose a couple months ago. That had a good turnout and a lot of interesting talks. This is always a good thing too. So August, no meetings. I didn't make this slide. Don't blame me for the puppy in the chair. So as always, announcements from the crowd. So are there any new jobs that people want to yell out, take their turn, say this, that, or the other thing? New projects, anybody wants to say something? They need help, they can help somebody, this, that. Completed projects, upcoming, other upcoming events that people like to mention here? Okay, that was easy. That brings us to our speaker, Alex Viera. He is formerly with Microsoft for 16 years, working on many things within SQL and the Microsoft BI stacks. Sorry, I don't know him personally, as being thrown in here at the last minute. What's really interesting, and specifically with this talk, is the area that he's working in, specifically around geospatial services. He's recently moved to SATA Systems, where he's working on both private and government processes using the geospatial. He'll talk about how they do that in a proprietary and also the open and cloud-based formats. I could try and color it, but it wouldn't make much sense. So I think I'll just say let's welcome our speaker Alex.
Okay. It's been a while since I presented in this room. It was weird to have to walk in here and fill out and get a badge to get in here.
Yeah.
I just wanted to give you my email address right here, alex.viera@statasystems.com. I'm sure a lot of people are going to have questions after we're done. My goal tonight is to kind of run you through the basics and then look at some very sophisticated applications, show you the value that's there. And then what I'm hoping that you'll take away from this is that you'll learn that a lot of the geospatial solutions that are built out there today that you might be playing with, they're really not that complex to build. The hardest part is gathering the data. You'll see that most data that you have sitting in a spreadsheet, sitting in an Access database, sitting in SQL Server, most of them have some kind of geospatial or geocoordinate information in there. And from that, we can take that and overlay that on a map. So one of the things I'm going to talk about today and we'll look at is really taking a look at how the API, I don't want to go down to the dev level because you can kind of look at it yourself, but it's amazing for how many few lines of code what you can build once you have the imagery or you have a latitude and longitude, and I'm going to talk about some of that. As you can see, I kind of wasted a few years here doing that one, but we're going to talk about some of the geospatial functionality within SQL Server and how that might play into this as well, because it's an excellent platform for building out these types of applications. As you can see, I'm a certified Bing Maps developer, but I'm also an uncertified Google Maps developer. I actually, now that I've been working at SATA, I probably know the Google Maps platform better than I know the Bing, so I can talk really fluid to both of them. So I'm going to be showing you demos on both sides today. Just we'll keep it neutral, and just so you know, like what we do at SATA, we're a Microsoft partner and a Google partner, so I'm not going to try to shade anything there. I'm going to learn about 6 terms. do as few slides as possible, and I want to spend the time in the demos. I think that's the most constructive way that we can spend this hour and really kind of go through things. I don't know what the timing will be, because I haven't done this presentation before, so hopefully we'll have time for Q&A, and I'll be available for at least a half an hour or more after we're done. The number one thing when you're dealing with building a geospatial solution on Bing or Google Maps is knowing what a coordinate is. And as far as a coordinate goes, it comprises of two pieces, a latitude and longitude, right? So when we take a look at a latitude, we're measuring that from the equator. It goes from 0 to 90 going to the North Pole, and it goes from 0 to 90 going to the South Pole, right? And if you take a look, that's where we're getting that 37.4 number right up there. That's actually this room that you're sitting in. That's the latitude and longitude of this room. I went and looked right before I gave this presentation. I wanted to give you something relevant. So if you were to go look up that latitude and longitude, you'd find out it's in this building. Again, you'll see that we got negative 22.07 there. That's negative going out towards the west, positive going towards the east. So we sit out here somewhere, and that's where we're getting that number. But you'll find in most applications that you're building, whether you're building them for Android or iOS or for the desktop, these coordinates is something you really got to understand, because you're always going to be converting either from an address to one of these lat longs or from a lat long to an address. Does that make sense? Okay.
The least significant digit, does that correspond to how many meters?
These are actually decimal degrees.
Decimal degrees.
Yeah,
Well,
and you'll see that when you pull it back from most APIs, they go about eight significant digits to the right of the decimal point.
Okay.
And one thing you can do sometimes when you're playing around inside of like Bing or something, you'll see in the URL, when you zoom in on some place, or you put an address, in the address title, you're going to see that it actually shows a lat long in there, and you can start playing with those numbers to find out when does it actually make a difference, so I can see it on the map. And you'll find that at the fourth significant digit, where the 5 is on like the longitude there, if you were to change that to a 6 and bring the map back up, you'd see it just move a little bit depending on your zoom level, right? So there's also a zoom level you need to deal with as well. Okay. Geocode, so when someone talks to you about geocoding, and if you're going to ever build an application that deals with maps, you're going to have to geocode. There's no way around it. You've got to know how to geocode and reverse geocode. And luckily, both APIs both give you this functionality. So what you're going to end up doing is some user comes in and types in an address like you do in a search bar, right? You type in an address, and what it basically does is it pulls back a lat long, latitude, longitude, and then what the coder's doing on the back end is saying, put this at that lat long and puts a marker there or something there, right? But those lat longs can also make up different shapes, like a polygon or a three-dimensional building. If you've ever been in Google Earth, you can see that you can build three-dimensional buildings, and so you can look at them in 3D. Those are just using lat longs and then another vector as well as far as the elevation. So you got lat long and elevation, all right? Reverse geocoding, why would we ever need reverse geocoding? See, so we're going from the actual latitude, longitude to the actual address. And again, all these APIs allow you to do reverse geocoding. The reason you need to do reverse geocoding, and you've probably seen this when you've gone to websites and it says, I want to know your location so I can show it on the map. Or you break out your Android device and it's asking you, do you want to show your location? All it's doing is getting your lat long, because that's all it knows is a lat long, and then what it's trying to do is reverse geocode it to give you an address. So that's how I can figure out if I wanted to know this address of this building, and I were to put it into my phone, it would go and look the lat long based on all the wireless networks, figure out where I am, and then it would go do a lookup and say what address is that closest to, right? Any questions about those two? Those are your two primary things that you're always dealing with. A lot of it is, some user enters into your application an address, you're trying to find out if it comes back with the correct lat long. There's some other cool things that you can do, like with doing geocoding and reverse geocoding, is you could take advantage of the fact that if the services out there, Bing or Google services, can't find that address, the user probably typed in something bad. So if they're filling out a form, one of the things you can do is you can take the input from that form and say, go geocode this. If it comes back correctly, then I know we're at the same place. Otherwise, they typed in something wrong, and it's a wrong address. So there's some really smart things you can do. They're not even related to putting it on the map, but more of being able to validate a form when a user puts in something. Because you think about what costs the most money for most companies is when they put the wrong address and you send something to the wrong place, or you drive to the wrong address. And that's the way we can get around that. Symbology, basically having different types of symbols, shapes, text, whatever it is that you're going to put on the screen to identify what you're putting at that latitude, longitude, whether we put a pin, push pin, or whatever we end up doing in that situation. Vectors, so most the APIs that you're going to develop these applications for are going to require either some kind of vector or raster images. So a vector would be a lat long. So if you take a look at a file that's going to describe a county, I want to shade a county in blue in a map, right? What I'm going to do is I'm going to give it a bunch of points that make up a polygon, but all those points are latitude, longitude. And that's why I'm saying you got to get real familiar with doing latitude, longitude kinds of things. And when you're processing those as well, think about the capabilities that you have within SQL Server for Geospatial. Most of us have never really touched those functions. But what you end up doing, and think about this, you have a database with a bunch of customer addresses. And what you want to be able to do is you want to be able to put all those addresses as little dots on a map so you can see the cluster of where your customers are. So what you're going to do is you're going to take those addresses and you're going to geocode them, and then you're going to have two columns in your database that you have to make, one for the latitude and one for the longitude. Once you do that, the geospatial capabilities within SQL Server, you can do some really cool stuff that says, I'm going to draw a circle on the screen, I'm going to give you that bounding circle. I want SQL Server to return me every customer within that circle, a radius search. Or I could draw a polygon on the screen, and I want to know every customer within that polygon. And that's what you're basically sending to SQL Server. You're giving it those coordinates and saying, return to me every point that's sitting within that boundary. Does that make sense? Yes. Because I'm going to show you some really cool applications that show that feature. So your vectors are basically ways of showing points, lines, and polygons. They're all kind of made up of the same fundamental. You start with a point, you can create a line by having 2 points, right? Or you can create a line having 3 points if it has a bend or whatever, or if you want to just make it make a point in a weird way. Polygons are just made up of lines and points. Now you have these things called keyhole markup language and also Esri shapefiles. Basically, KML was designed for Google Earth for creating a bunch of shapes. You drag and drop, you create all these polygons, lines, push pins. All you're basically doing is putting lat and longs together. The same thing with Esri. You're putting lat and longs and attaching them to some kind of shape. Esri goes much farther than that with these shape files. You can do some really amazing stuff and basically use the shape file or KML as a database, because every object that you put inside of one of these KML files or Esri files can actually have data associated with it. So it's almost like a database because there's metadata associated with every polygon. What color do I want the polygon to be? What are some of the demographics in that? What state is that? So I can put a bunch of different information and tag the KML file or the Esri shape file. So it's just a way of pulling together a bunch of shapes together and putting tags on them with extra metadata. Raster images. Basically, you can have TIFF, PNG, BMP, JPEG, whatever, and essentially these are the things that you're going to take and put and show on top of the map. And I'm going to do some floor plan layout stuff that I just did for a customer just recently. I have a beta that I'm going to show to you. And basically what I did is I took some of their files that they gave me, overlaid it on the map so that they could do some really cool stuff as far as floor plans go. Okay? Any questions about that?
Does it take GeoJSON?
What's that?
Does GeoJSON work too?
GeoJSON would actually be an output of some of the calls that you would make, but most services that you call On the Google or Bing, on the Bing side, will return GeoJSON or XML depending on what you want returned.
Okay.
And so it'll basically give you records. It's not going to give you KML or Esri shapefiles, but most services, when you pull that back, you'll be able to do that. All the vectors can be taken in as GeoJSON, and then you can actually code that up because you're going to have all the lat longs in there, just an array of points in there.
Okay, but just as an initial input though, it won't take GeoJSON?
No.
Okay.
Very valid format though. I'd say, you know, as far as doing JavaScript and any client stuff, the JSON part of it you end up using a lot. GeoJSON is something else that you just have to parse out a little bit more to get more information. It's actually more information that you want to use.
Yeah, I mean, I only ever use GeoJSON just because there's JSON parsing libraries for everything
Yep.
else already.
I don't think I have to tell anyone that, you know, maps have transformed our lives. I mean, basically, when I worked with Microsoft along with my buddy Joe back here, I mean, I used to drive 60,000 miles a year before we even had, you know, this was in '97, and it was a really pain to have to print stuff out and hope that you get there. I mean, when you really take a look at how our lives have changed and not having to train anyone, and I think this is a big thing too that I wanted to talk about while I'm remembering. Because a lot of vendors are going to come out there and they're going to go, don't do this on Bing, don't do it on Google, you know, you should do this on Esri. One of the biggest things about being able to do it with Bing or Google is the fact that if you create an application, and this is something you should think about, if you create an application, you're not going to have to train that person how to use it, except for a couple other buttons and features you might put in there. But everything else, I don't think there's one person in here that can't get on a Google map and know how to use it, right? It's just, and I had some other things I wanted to talk about, but I'll kind of get through this. You know, we have cars integrating this information, a lot of things that we can do as far as custom applications go. The social aspect of it, you know, everyone has an idea of some kind of cool app. What's really nice about this, and one of the things I really like about the aspect of doing map applications is that it's something where the back-end server coders never get any credit. It's always the front-end guys that get all the credit because they have the nice and pretty thing. That's a cool thing about creating these applications. Very little code, a lot of flash, and a lot of usefulness. Just kind of looking at, you know, we can take this data, and now we have availability 24/7 to see information and being able to plot things on here. I mean, if you take a look at an application like this where, you know, from the time you start work to the time you go home, having applications that are really amazing applications that can really help you get to and from work. I was kind of surprised it takes, for 1.7 miles, it's 21 minutes, but I guess that's a lot shorter than my drive from Santa Cruz. So what can we do for business? So again, a lot of data out there, and a lot of different ways to be able to visualize that data. And one of the things that makes this kind of hard to deal with is that, and I'll kind of segue into the next slide. I think this is the hardest thing, and these next two slides represent the hardest thing. When you're dealing with an organization, a lot of times if an organization has a group that's just a geospatial group, that's all they do, they're the Esri people that own the data for doing all the mapping stuff. This is their golden palace. They don't want to give up their golden palace. And what you're trying to do is you're trying to take the data and share it with everybody and make it very useful. And I think this is one of the hardest things here is that organizing and managing the data and getting it into some common data storage where you can make it useful, and also having accessibility to it. So, you know, whether you're taking advantage of master data services or something like that, you do need to deal with the kind of the politics involved with getting that data so that you can display that data, right? You can do really simple things as far as even getting data in a spreadsheet and uploading that to the server and being able to display that. As long as it has address information in there, a lot of the servers will go up there and geocode that automatically for you. There's no code to write. You just put the spreadsheet up there. As long as there's a column with the address, boom, it's going to show up as a point, and all your other columns inside of the spreadsheet show up as metadata that you can choose to show or not to show. Just to give you an idea of the ways that, you know, people take advantage, and you've probably seen different websites that kind of do this kind of stuff. This was for, I think, Hurricane Sandy. And, you know, they wanted to have a lot of different types of information overlaid. And what you'll find is road conditions, traffic conditions, a lot of different things that you get as far as weather. These are all things that are freely available to you. You just need to turn them on inside of the application. Google and Bing Maps both have weather layers. So all you do is, it's one line of code. Boom, show the weather layer and set it to visible, and all of a sudden it'll show up with the clouds and it'll show up with all the temperatures. The same thing with all the traffic that you're seeing. That's a freebie. It comes in the package. So if you're trying to get from point A to point B, you know, they're tracking everyone's cell phones and stuff so they can see what's green, what's yellow, what's red. You know, you can see there's some kind of little red going on right there. Being able to take other information, you can see that some of the information was from a KML site. So if you go onto the internet and do a search and look for KML files, you'll find them all over the place. A lot of weather service places offer that information. There's a lot of different demographic type of information out there as well that you can take advantage of for being able to display on your maps as well. Okay, so let me talk about this and how it works from the perspective of after you've gathered the data. One point I wanted to make today is that when you're using either API, whether you're using Bing or Google Maps, if you're creating an application that is available to the public at no cost, it costs you nothing to use the API. It's free. The minute you make someone sign in or you're charging for that website, then you need to start paying. And it's not cheap. I'm not gonna lie to you. On either platform, it's not cheap. If you're gonna write an application for internal use, let's say you're gonna connect to Salesforce, you wanna integrate to Salesforce to show where an employee is gonna go with different customers throughout that day, that's an internal app. That's money. It costs money to do that. So again, anything you do free, just playing around, because it's very easy to play and create some really cool stuff, but the minute you bring it internal, you need to start paying, okay? What does that cost look like? I'll just give you an idea of some of the base costs for doing it at a business level. The minimum it's going to cost you on Google, because I know this for a fact, because I'm more consistent on that side, it's going to cost you $10,000 for the minimal license. What does that get you for $10,000? Your $10,000 gets you 100,000 map loads. There's a measure of quantity called a map load or a page view. They use those interchangeably depending on whether it's free. So the free API is considered a map load every time you load the map. If you're paying, it's considered a page view. They're two different, confusing. It's like if you ever look at the licensing, it's totally confusing. But I'm going to prep you for this because I don't want you to build this crazy app, show it to someone, and all of a sudden it's like, oh, you know, terms of service situation. So you bring up a map on a website internally. Let's say you're doing this for your work. Every time a map is shown on the screen, that's one load. Every time you hit F5, that's another load for each F5 key that you hit. If you do some bad coding, and I just dealt, if you go to Harbor Freight, you've ever shopped at Harbor Freight? I just dealt with Harbor Freight. They had a disgruntled employee, coder. What did he do? He went and put the JavaScript include in the header, and then he obfuscated all the code in the script header. So what happened, and this would happen up to like yesterday when they made the code change, anytime you went to any page inside of Harbor Freight, it would actually do a load of the JavaScript API for doing a map. So it's not just showing the map, it's actually loading the API. Does that make sense? Because to load a map, you need to load the API, but the minute you say include the API in the header before you even show the map, that's what your money. You can do anything you want with the map at that point. You can scroll to the left, scroll to the right, change from satellite view, do anything you want to. As long as you don't go away from that page, it costs you no more than that one page view. So what this person did ended up making them go from, how many hits do you think, how many hits a day do you think Harbor Freight gets? they get 1 million, okay? It normally costs, for that 1 million hits, it normally costs them roughly $90,000. They went to 40 million hits in a day. So you can see the math there. So they were lucky because the powers to be forgave them and said, we realized that this was not your normal range. And then they had to make the change within a certain amount of time, but there was some forgiveness there. My bottom line is, if it's not public, you're paying for it, and it's based on a cloud model. The cloud model is usage and consumption. How much do you use and how much space do you use? Because some of these services like Google allow you to put all your images up on their server, so you don't have to host anything. And I'm going to show you an example of that. Okay, got a little sidetracked, but I figure that's good knowledge so you don't go wasting your time creating a cool app and then find out it's going to cost you 25 grand. And that's one thing, as people start using your application, what's going to happen is if you talk to a Google or you talk to a Bing Maps representative, the first thing they're going to ask you is, how many hits do you get? You need to know this information. How many hits do you plan to get? And that's how they're going to charge you. That's how they're going to figure out how much to charge you. So that should be the first thing in your mind if you're really going to go and do this at a commercial level.
Question.
I'm kind of curious how that billing works, because the request for the API call can come from anywhere, right?
If it's internal, no. External, I don't care. If it's public facing, I don't have to worry about it. I'll get 25,000 for free unless you create some website that's just getting millions and millions of hits. After some point, it's not free anymore. You're using resources. But both Bing and Google are very generous in what they give away. If you're getting 25,000 hits a day, that's a good problem. You better put some ads up, do something like that. But they're going to charge you based on different levels, and there's different discount levels based on your usage. So when you come to them and say, okay, I expect 1,000 employees to go onto this website and do 10 searches each and da-da-da-da-da, and how many keystrokes and whatever they might do, you want to plan for the worst case. They're monitoring everything you're doing. What you're trying to do is for that first year, you're buying a year's worth of hits or page views. You're trying to get it within a certain area. If you start getting close to the end of that, before the end of the year, they'll let you know at like 70% and 80% and 90%, so you can redo your license and figure out what you're doing. If you grossly overpay, what will happen is that you won't grossly overpay in the next billing cycle. They'll drop it down, and then you know where you're at. But you also have a console that shows you how many hits you're getting, so you can log it. It's like a web log.
Did you just say that if it's a public app, you don't have to pay, but if it goes over 25,000 hits, you do?
Per day.
Per day?
Yeah.
Well, still, but you have to, it isn't like you never have to pay.
They're very lenient. They're not going to shut your website down. They're going to contact you. They're going to let you know. It's like, hey, you're doing some really good things here, obviously. You have to work it out. What I found with Bing and I found with
You're talking
Google,
about downloads, not hits, right?
I'm talking hits.
Hits?
Hits to the website.
Every object on your website has a hit.
No, I'm talking every time you load a page with
That's
a
a
map.
page load.
Page load. Okay. So what I want you to take away from this is that we have markers that we're going to put at a different lat long, right? Some coordinate. We have different charts and graphics we might show. This might just be a graphic chart that we're showing that has nothing to do with other than putting that on top of a map to show the user some information. Having some kind of trails and showing history for doing asset tracking. Let's say that you have a GPS monitor on the bottom of someone's car and you want to track where they're going and how fast they're going. Easily done. We can take that data. We can take the polygon up there with the different points, and we can do floor plans as well. So we can do a bunch of different things that we can take. We take all this information, and what we end up doing is putting it on different layers. So Bing and Google both have this concept of having layers. You have layers of data that you can turn off and on, right? So you can set the Z level, and then you can also set the layer of what you want to show, and you can also set transparency. So I might just want to show some shading in every zip code, but on top of that I want to show a customer point and show some other information. Or a building, I'm showing a building floor layout, I want to know all the rooms that have projectors in them, stuff like that. So as you can see, we can build up multiple layers, put up different kinds of graphics. You're not stuck with the graphics that they just give to you in any of the SDKs for building out this stuff. A lot of this stuff, these are just the general kind of markers that you can use, whether it's a push pin or a thumbnail or whatever it looks like. But you're able to do some pretty amazing things here. It's just a matter of you being creative. And then once we do that and push that out, we can push it out to the public. I don't know about this underwater thing, but it's kind of stretching it. Okay. So let me get out of here and let's go to the demos. Okay, so if you search for the Bing Maps Ajax control, just search for Bing Maps Ajax control. This is where I want to just show you the basic. What I want you to take away from this first part of the demo is how easy it is to be able to do this stuff. I mean, you don't have to be a rocket coder to be able to do this. You don't have to be, you don't have to have heavy development skills to do this. A lot of it you can do with cutting and pasting. It's pretty amazing how much you can get away with without paying anything for tools. I mean, you can use a debugger inside of the browser for doing a lot of the JavaScript decoding. And I did a lot of my first maps just using Notepad until I got smart and realized I could download NetBeans or even Visual Studio Express for free. But anyway, you can see all they're doing here is they're just creating a new instance of a map. They're giving it some credentials, and it's just putting a map on the screen. There's no centering or putting any markers on. That's kind of where I wanted to go next, is kind of going to the push pins.
So this is all Java based?
There's a client side to it, and there's a server side to it, all right? The client side is for being able to show the graphical part of it that you can take advantage of. There's other tools out there that you don't have to do any coding, where you can do a lot of stuff visually dragging and dropping, and then being able to import that, like I was talking about, the KML files. There's a server-side component for a lot of the geocoding. So if you're going to write an application that does some geocoding or something fancy, direction finding, and I want to do it on an Android or iOS, I'm probably not going to be running JavaScript on the client side of this, right? What I'm going to be doing is I'm going to be using their SDK, and then I have web services I can call that can do everything I'll do here except for the map calls. The map calls are almost identical. Like if I took this line of code and tried to do it on this device, it would be identical. So they're very much one-to-one. The things that you don't get is a lot of the JavaScript type of things that you can do. Like on the JavaScript side, you can do a geocode or reverse geocode using the APIs versus using the JavaScript on the client side. I don't know. Did I answer your question?
No. So the question is that the only language this operates on?
No.
Or can you use something else?
You can use anything you want to, basically.
Well,
right?
Like what? I mean,
I could do it in Python. All the stuff I could do on there, I could do it in C#. Basically any of the .NET. When you're actually doing the browser stuff, though, getting more specific to doing this on the browser side, in this side, you're going to end up using JavaScript. But for all the other stuff you might do on the server, you can use any language you want to. That's just all web services. Okay, so what I wanted to do was take a look at adding a push pin. All right, so take a look at the push pin. What did they do to put that push pin? They said new Microsoft push pin, and they said give me the center of the map. Guess what this get center is bringing back?
lat
It's a
long.
lat long, that's all it is. I could have gone in there and typed in a lat long that we have, and it would just show up on the screen. And there's different kinds of push pins as well. You can make it so the push pin can move around. If you move the push pin around, you can talk to the push pin and say, what's your lat long? And I can get that back. So you can see that I could do some cool stuff. I could put 2 push pins down, and I could draw a line between them, and we could use that as a measuring device on the screen, right? I could have a bunch of them and create polygons that I can expand, and I'll show you how that query would actually end up working. The last thing the 2 other things I want to show you here. Here's a polyline. If you look at the polyline and just look at what they're doing, they're taking the lat long of the map and just adding a couple numbers to it. just to make it draw that shape on there. Let's do one that's a little more complex. There's a custom polyline. Let's go down to like polygon. There's your polygon. And again, if we take a look at the polygon, I can't get that scroll to work there, but if you take a look at the polygon, all they're doing is creating a polygon by putting a bunch of lat long. So they're just telling it where to put all those points on the polygon. It's that simple. Polygons have a bunch of different features. Like I said, color, transparency, Z level that you want to be able to set. And lastly, before we move on to the next example, I wanted to show you the info box here. Let's see, info box with multiple options. An info box is just another object. You can put any HTML you want to. You can roll your own. And all you're doing is when you create an info box, you're saying put it at this lat long, right? So when you need to show information about a certain object, you're passing a lat long. And notice what they did here. They said map.getCenter. That's all it's basically doing, is giving it the lat long. So we're able to put that in that way. So that kind of formulates the basis so that when I'm showing you these other examples, I just kind of want you to roll back to some of these I'm showing you and going, okay, I can see those are just points. I can see that's just an info box. That's just a push pin. I mean, it basically is that simple. So let's go ahead and take more complex stuff. City of Chicago. City of Chicago has, time's flying. City of Chicago has all these different departments. Department of Waterworks. I mean, if you take a look at all the different agencies, right there are all the different agencies that work in the City of Chicago, right? You have, I just highlighted gas, water, and electric. But you have sewer, you have railroad, private, state, all these different things, right? So this is an application that we wrote for the City of Chicago. It's version 1. And I want to show you, this is one of the things that really impressed the hell out of me as far as doing a map. Because sure, you have data in a spreadsheet, you can show it, you know, some cool things you can do. What this actually does is the code that sits behind this actually can look at each project and say, where do we have conflicts? Because I don't want some electrical guy or some road person to go in and fix and dig up the ground, and then I have to come back 10 minutes later, or not 10 minutes, but I have to come back in a month, and I have to dig up the ground in the same place. So I want to know where we have conflicts, because I might be doing something with some water mains, and I want to make sure that the electrical guy is not going to be there because I don't want their trucks in my way, right? Think of all the different scenarios. So what this is this is a conflict resolution manager, and it gives them a front end to be able to do this. This is a very high-end application, and this is what they're actually using to do this. Now let me show you something here that's really cool. I want to turn on all the conflicts. Every one of these red things that you're seeing on the screen, the symbology, means that I have a conflict with another agency, that we're going to try to do something, but that other agency is going to be in our way. I also have the reverse of that. Show me all the opportunities where if I know that someone else is going to be working there, I don't have to dig up the ground twice. Let them come in and dig up the ground. We'll do our work in conjunction with them.
Okay, that sounds great. Where does this data come from? How do you get the data into the application?
Okay, so they have the data sitting in a bunch of different third-party applications, and what we basically had to do is go in there and say, we need to host this data and make basically a copy of it. So we're pulling this into a database, and then we're running this logic in here to look at the crossover dates between the different projects and the Latin longs, right? We're seeing if there's a Latin long that's within, I forget what it was like 200 or 300 feet. If someone's within 200 or 300 feet of us and they're going to do a job in the same overlapping time frame, we consider it to be a conflict. Then I can go in the tool and I can take a look. So let me kind of show you that.
But if the project changes, you have to update your data then.
It'll automatically update based on what they end up doing on their servers. So we're actually, we're doing this all live.
Can you turn them both on for a second?
Do what?
Can you turn on the opportunity and conflict?
Why would that be?
Yeah.
They're pretty much the same.
No,
Sort of. I mean, a lot more.
Yeah, so let's take a look. Let's take a look here. Let's go ahead and take a look at a conflict here.
Isn't the word for opportunity and conflict the same in some language?
Let me,
Every conflict's an opportunity.
this might be a bug in the application, but let me see if I can bring this up. So basically what it is, and I mean, this is a full-blown web application here, looking at the different agencies. So you have ComEd, and you also have conflicting agencies, some private company that's doing something, and we can go look at the permits. I mean, if they have permits here, maybe they don't have any permits. Looking at linear conflicts, if we're going to do something on the ground and stuff like that. One of the cool things here that I really like that they did with this application is I can zoom out a little bit. Hang on one second, let me get a good view here. I can tell you all the permits, and this is actually live. All the new permits starting from July 1st and ending July 30th. And so what that should do is go in there and show me all the permits that have been pulled. So you can see that we have a permit right here. And I can go look at that permit for new construction that was actually done. So it tells you what they're doing, renovating and doing the exterior of a courtyard. Now, one of the things they wanted to do here as well, I mean, this is the city of Chicago really wanted to do a lot with this. Moratoriums. We can look at moratoriums as well. Let me go ahead and bring up one more thing I showed you before I move on to one more thing I wanted to end with.
What kind of moratorium? What do you mean moratoriums?
As far as street construction and different things that they want to be able to put off, let me just find this. Here it is. I wanted to find the water. They had some water main things I wanted to show you because that was something that was really interesting as far as haven't played with this application enough. One thing I want to point out in the upper right is we can show traffic. Again, traffic's a free layer, very simple. We can show satellite view if we want to switch to satellite view. We have PegMan here, so if I want to look at what's being done in that area, I can basically go down on the street, figure out what I might need to close down, what buildings might I affect, look up, look down, figure out where the manhole cover is, right? Simple stuff that if you're having to do the work out in the field, you want to have that situational awareness. Okay, let me end with this, and this is something that you guys can go look at as well. It's a visual fusion analyzer. Now, one of the things I really like about this, it's integrated with SharePoint. But one thing I can do is I can go show where all my customers are. Again, see how it's showing where all the customers are. And I can go in and zoom out. But they created a tool palette up here. And with the tool palette, I can do a radius query. And I can do a query to find out who all my customers are in that area and find out how they're doing that. Now again, remember that all your points of data are just lat longs that are probably sitting in a database somewhere, right? So when I create this radius, all I need to do is go up to SQL Server and say, here's the center point, and here's how far out the radius goes. Tell me all the bounds within that. From that call, I can pull down all the records and display anything I want to, do a report, push that report out to wherever I want to. I want to pull it out on the web page. Heat maps, I can do heat maps as well. So we can go in there and take a look and do heat maps to figure out where the highest concentration. Notice when I have the highest concentration of customers, you see it a little bit different in color there, right? State aggregates, just a KML layer with some transparency. Notice with this KML layer, we have the polygon, and we're just setting this to the transparency level. This transparency level is probably level 1. as you go up higher in transparency levels, it gets more transparent, or you go down to 0 to make it a solid color. Notice that also when I go over it, there's metadata associated with this KML layer. So as I go over it, I get an info window that's meant to track the finger there as I move around, or I can go down as far as getting information about a specific name and address for a point in there.
So which one is this using? Is that using Microsoft or is this another?
No, this is actually using Bing. That's one thing, is that what you'll find with using either one of them, they all deal with markers. It's the same terminology. It's markers, layers, polygons, and it's basically that's what you're doing. Street view is something that you turn on and off to get that looking around view. Satellite to map view, those are just changing the underlying map. That's just like one call. You just set it, you tell it to set its type and do whatever you want to do. When you're dealing with the Android and iOS SDKs, it's almost identical in there what you're doing. If you go and look at it, it's almost, they use the same names, they use layers, they use markers. You load this, you load that. It's very simple to do.
Is that a private application or is it
This one is a demo application that you can go to idvsolutions.com, and they have a bunch of different demos up there built on Bing. The emergency response was built on Google. I built that. That's version 1. I haven't even deployed that yet. And the CDOT application for the city of Chicago, that's actually a live application that they're using. That was built on Google. I didn't show you a lot of what that application does. It does a lot of things on the back end as far as reports and scheduling and being able to modify. It's a full-blown web application. And to give you an idea of the cost of that application, that was $4 million to build that application. It's very robust. I haven't even played with it enough to know what it can do, but I've seen some of the reports and what it can do. And as far as running the city of Chicago with all the different utilities involved, that's the application that the city of Chicago uses. That's about all I had for you. I hope that was informative. I'll be hanging around for a little bit longer.
Oh, it's a question time?
Yeah, question?
Go ahead.
What is the query? Did you use the SQL Server query to get that all
Yeah.
using the radius here?
Yeah, so if you go and do a search on radius query SQL Server, you're going to see it's part of the Geospatial library. All the databases, I mean, SQL Server, Oracle, MySQL, they all have some geospatial capabilities. The top two in my eyes are probably Oracle and SQL have the best geospatial capabilities that no one takes advantage of. I don't know why.
So
But
see, that is SQL 2012, right? Not 2008.
Joe, do you know when it came?
2008.
2008?
It's there?
Yeah. Yeah.
Because I'm doing the same thing in Oracle, but I don't know.
Yeah.
2008 SQL.
Yeah, SQL Server has it. There are some third-party libraries. If you, let's say you wanted to do an access and you don't want to do SQL Server or Oracle, there are other components you can buy that have the algorithms in there that you pass into lat long, and you give it the column, and it'll tell you everything that sits within that boundary. But remember, you have different shapes. I'm doing another project where this insurance company wants to know when storms are going through the United States. When they see that KML layer, that polygon for that storm, they want to be able to see every potential customer that might get hit when they have hail that's over an inch in size, right? So there's a bunch of really cool things you can do with a query, but the query might not always be just a radius or a polygon. It could be a donut. It could be some very odd shapes that you can do. I know you guys are having this big data battle, but this is a perfect grounds for if you're looking at taking that kind of data. I did a big data project for a fishing company, and basically what they had is they had all these records, millions of records from all their fishing records, and what they wanted to do is they wanted to correlate El Nino, different temperature patterns, different weather patterns, and be able to look at where they caught fish before over like for the last 50 years that they could have the recording. And they had, a ton of data, and all they were doing was very simple. It was basically it was a map-reduced code that all it looked was for certain words like tuna and what latitude and longitude, then looked at what day of the year it was, and what they were able to do is put that on a map and show all the hot zones during the different times of the year over a vast amount of data. I mean, you know, historical data from NOAA, the fishing data that these guys had. It was just incredible use. And the MapReduce was really simple. It was just a keyword search. Just looking for how many times did you see tuna, and then when you saw that, what were the latitude and longitude? It was amazing value that came out of that. Another question?
Oh, I was just curious, like, if we have multiple KLM files,
Yeah.
so then like they can do, they just select, so basically it's just a polygon, and then basically I want to know if the user can select multiple, which one they want to search by and display.
Yeah. So if you have a file that has a bunch of KML shapes in it, what you're going to end up doing is basically you parse out of that file all the different coordinates that make up the polygon in that file, and you would pass that to the database and say, tell me everyone that's inside that, and then I could put up the markers, or I could send an email to all those customers, depending on what that data is.
Yeah.
So just to give you an idea, Fireman's Fund up in Nevada, I did a project for them. Same thing. They had a tornado that went through an area, and so you basically drew a polygon around the area that they were given from NOAA, right? And then what that would do is they had the projected path. So you take the projected path, and it would say, in our database, find us every customer that's sitting in the projected path and send them an automated phone call and tell them where the nearest center and give them information to call us is with.
Tell them just drop their insurance.
and then what happens is after their house got wiped off its foundation, the agent could go out there, take a picture with the camera, and since every time you take a picture with your cell phone or a camera, it GPS encodes it, and that person would just email it to the server, and it would show up automatically in their central location so that all the agents could see in their command room, they could see what that damage was so they could respond a lot quicker. There's some really cool things you can do with that. I don't know if you take a look at some of the information in your cell phone after you take a picture, it has GPS coordinates on there. So you can do some pretty amazing stuff.
Is there any database where you have everything like latitude, longitude, city, state? Can you get a database?
Yeah, well, you can buy a lot of that information. Like one of the projects I had to do was for Walmart. They wanted to plot everything on the map of where all the Walmarts, and for some reason it's like I couldn't get a hold of the right person within our organization to get it, and it ended up there was some other company I had to pay $50, but they gave me an Excel spreadsheet. I just imported that Excel spreadsheet into the database, and then I had all the information. I geocoded it, and then had it all there.
You know, what I'd like to see is how you integrate the code in the database with your graphics here.
It depends on what you're trying to do, because I can pull the images from the database as well.
Can you show us the one of your apps that you designed? How you've actually, I mean, we're code slitters.
Give me the example of what you're trying to do, and I can walk you through it.
No, just in what you were doing, like the Candlestick Park thing.
Well, Candlestick Park, I mean, I'll show you. I'll share something that I probably shouldn't show.
Running a little late, so Alex will be here for the next half hour, so let's get him
We'll end it with showing a piece of code. The way I wrote this application is I made it so that I could load layers based on an Excel file because I didn't want to have to recode every time I did this. So I basically used an Excel file as my way of building those menus you see on the right. And essentially what I do is I have all these different layers, and based on what type of layer it is, I just do a set map to the map, or I set it to null. Guess what setting it to null does? Makes it invisible. That's how you turn a layer on and off. You either set it to a reference to the main map, or you set it to null, and that's what turns everything on and off.
So you use layers metaphors?
Yeah.
Is there support in either of the two DBMS you mentioned for 3D geospatial queries, like is altitude?
Altitude is in the API in the Google side. I don't know about the Bing side, but there is an elevation API as well. So if you're doing something where you're traversing a mountain, you can actually you can give it GPS coordinates, and what it's going to do at that point is tell you the elevation at that point. So you can do that as well. If you want to write an application for, like, say, mountain bike riding and it goes from point A to point B, you could actually show a profile of the elevation and show whether they're climbing or going downhill. That's part of the API as well.
Do you know how, or if those queries for like 3D geospatial information are disproportionately non-performant compared to 2D ones?
I don't know.
Okay.
I'm mostly dealing with 2D stuff on top of Google and Bing.
You can download the elevation along from NOAA website by counties or their 30-meter
Yeah.
elevation data, or even like what you're asking for,
But-
zip code and CBG
Yeah.
and all the that one.
But this is something that the API gives you. If you give it any lat long, it'll tell you the elevation of it. So you can do some pretty good profile stuff to like slice off a mountain and figure out what does it look like from the side. Is it a steep climb or what it is?
Okay, I mean, but when, or if you put that into a DB, do you know, again, or you said you don't really know about performance?
Well, once you put it in a database and cache that information, if you ever go back to that geolocation, I mean, that's part of the thing of we didn't talk about is speeding up the performance, because if I do a geocode and I know the address, I always want to look up the address in the database first and see if it's geocoded. If it's not geocoded, then get it back. There are some terms of service things you need to be aware of related to doing geocoding, and that falls within the line of you can store the data for a month in your database, and then you have to refresh it. That's the terms of service. Because what they don't want you to do, what Bing and Google don't want you to do, is they don't want you creating your own database of geocodes and then selling them.
Do they have any way of figuring that out?
Don't know.
Okay, let's thank our speaker again.
You have my email. If you have any more questions, please feel free to send me an email.